Don't let your relay go up in smoke. I'll be covering the 4 disastrous mistakes made when wiring relays. Hi, I'm Gary Gray. Welcome to Wiring Training, where our aim is to educate and have fun in the process. I've been an electrician for 46 years and I've learned a few things over those years which I want to pass on in this video. I remember the first time I wired up a really basic circuit and the fun I had in the process and the great delight when I flicked the switch and it actually worked. Nowadays I still enjoy wiring up circuits, but they're a lot more complex than what they used to be. Only work on low voltage wiring unless you're a qualified electrician. Life's too precious to risk handling mains wiring if you're not qualified. So I've got a collection of relays here which I'll show in front of the camera shortly, but I want to cover what is a relay. The short answer is a relay is an electrically operated switch. When we apply voltage to the coil of the relay, a set of contacts operate and that actually switches the load, whatever we want to switch, whether it's a light, a motor, it's numerous. A relay at its most basic level consists of a coil with lots of fine wire wrapped around a metal former. There's a plate that's on a pivot that gets attracted to the coil when it's energized. The plate presses down on a movable contact and we have a fixed contact in there as well. So we'll wire this up. We need a power supply. So I'll take that around and connect to one side of the contact on the positive. The negative will take down to the load. In this case it's just going to be a globe. And the negative also goes across and connects to one side of the coil. The other contact brings positive down from the battery to the load once the relay is energized. Now we'll connect the voltage up to the coil so it becomes energized. So now our internals change slightly. We find now that the steel plate gets attracted to the coil due to it becoming an electromagnet which magnetizes and pulls the steel plate towards it. The steel plate pushes on the contact which then makes with the fixed contact and we get a circuit of electricity going through our load. Now once it's de-energized, there's a small internal spring inside the relay that pulls that metal plate back. Okay, so I'll go through some types of relays. I'll just show a few different ones. There's very small miniature relays which in my early career, part of the career, I didn't even know existed, and are quite fascinating. This is a couple of different brands of relays and you'll notice how slim they are. The actual relay itself is the white section here, and all this other part is the housing and where the wires actually get terminated. So if I flick that lever and pop that out, that's the actual relay itself. It's amazingly small. So I'll clip that back in. So that's actually a solid state relay, and I thought you could only get this size in solid state, but I recently discovered that you can actually get the mechanical type with a physical coil in the same profile, which is amazing, and that's rated quite high voltage as well. Now the other thing is we've got various types of printed circuit mounted relays, such as this one here. We've got very fine pins for soldering onto a circuit board. This is another type here, and then we've got a cluster which is a relay board with multiple relays, and that was actually purchased to program onto an Arduino for home automation. But just so you know, they are available, that type of thing. And then we go on to other types of relays, the larger stocky ones that I was very familiar with in my early part of my career, until I discovered the very thin ones, which are very handy when space is at a minimum. Now a common one here you may find is used quite a bit for driving lights on vehicles. So for headlights, that type of thing, and they plug into a socket. I've got two here coupled together. We'll pull it apart. So that's a socket which this one will go directly into and plug in there, so you can remove it if ever it goes faulty. And then we've got high current style. So this one is only got one set of contacts. I've pulled it apart so you can see internally, but it's not that helpful. It's still very hard to see what's going on in there. But this one's rated at 40 amps, which is quite a lot for a small relay. And the internals I've got here are pulled out of a latching relay, out of that housing there. And being latching, it actually has a different, you see this is normally a solid former in a coil, which creates, when it's powered up, it creates an electromagnetic field and pulls a plate which is called an armature and operates a set of contacts. In this one it slides backwards and forwards and actually latches, so when you put power on, it moves the contacts in one direction. When you put power on a second time, it'll move the contacts back the other way. So a normal relay, when you take the power off, it changes state back to its original. Now we get larger relays. This one was in a box that was labelled a relay, but it's a bit questionable whether it's a relay or a contactor. This one here is actually called a contactor. Now it's a really grey area. Contactor or relay. When do you say one's a relay and one's a contactor? You can't say the rating, because sometimes this might only be rated at 32 amps, and the one I showed you here a moment ago is rated at 40 amps. So this is actually a higher rating than a contactor of this size can be. This particular one, it all depends on what voltage you apply as to how much current will go through that. And then we move on to timing relays. So this relay, a lot of contacts on the base. It's actually got an analog movement on the front here, so you can change the time that this takes before it operates. It's quite useful if you want a delay before, once the power's applied, a delay before it actually switches. So that can be quite handy. Now the other thing we need to note is the various voltages. Now sometimes, like this one, I don't know whether you can actually see on the camera, it has a writing, a written label on there that states the voltage of that, as does this one here. They physically look identical, you can plug them into the same base, but one is a DC relay and one is an AC relay. I'll go into that later, but you often cannot use an AC relay on DC or vice versa. Right, so now we'll go on to cover some different base types. I'll just round up a few. So we've got, these are becoming less and less common. This is a round type of base, an 8-pin round, and they're getting more and more replaced by flat pins. Now we've got this type here, which is smaller profile, flat pins, and the actual wiring in here isn't through a screw terminal to tighten it up. It's actually spring loaded. You push on the front there and it releases tension on a spring. Once you remove the screwdriver from that point with the cable in, it clamps. So that's that type. Now I just want to show, when I find it, here's a good example here. The face of this one here has got a little orange bit here. When you operate that lever, it actually moves those contacts as if the coil was energized without actually having to energize it. Very handy feature, and there's quite a few you'll find. Here's another relay mounted on a base here. This one here has got a blue tab there that you can push in to operate the contacts, or you can flick the lever around if you want to hold it in that position. So why do we want to use a relay? Well, one of the things about a relay is the fact that it's very powerful, being able to use a very small current to operate the coil, but the contacts can have a very high amperage rating and switch quite a large load. If you take the example of a vehicle, when you turn the ignition, the starter motor starts the car. Now the ignition switch is only capable of very small amperage, and fine wire runs under the bonnet to the starter motor area where there's a relay. So we only need a small cable with small current going from the ignition switch through to that relay that's mounted near the starter motor. Now when the starter motor gets powered up via that relay, it can draw 200 amps or more, a very substantial load. So it has a very thick cable going to that starter motor that's switched by the relay. Another reason is for driving lights on a vehicle. Sometimes driving lights can be very high amperage, and we only want small wiring in the dash or under the dash because it starts getting very bulky if you ran heavy cables. So we just run small cables to that, have a relay with quite a large amperage under the bonnet, and heavy cables can go to that relay and then off to the lights. Okay, so that's got the basics covered. Now we'll go through the 4 disastrous mistakes. Now mistake number 1 is using the wrong type of relay for the power supply that you're using. Now it's referred to AC and DC, I'm sure you've all heard. AC refers to alternating current, but I find it's a lot simpler if we talk in terms of voltages rather than current. So if we say alternating voltage, such as mains wiring in houses, the voltage goes up and down from positive cycle to negative cycle and back up to positive, and it keeps doing that 50 or 60 times a second. So it's rapid change of positive and negative voltages. Now DC, on the other hand, or direct voltage we'll say instead of current, so direct voltage is similar to a car battery or a torch battery, where it's just constant straight line voltage at whatever level, 12 volts, 6 volts, whatever it is. It doesn't change, not like alternating. Now if we decide we're using DC, we're using say 12 volts of a car battery, we want to use a relay that's rated for DC on the coil. Now the one thing that you can get confused with, which is a mistake I made many years ago, I looked at the side of a relay and I thought it had the correct rating for what the purpose was I was using it. I was called to work at a dry cleaning store in our local area on a machine that had gone faulty, and through my testing I found that there was a relay that had failed. So I looked at the side of the relay to get the ratings of what voltage it was and current, and I purchased a similar one, I thought. However, I was caught. The voltage I looked at on the side was actually the contact rating, not the coil, and I actually purchased the wrong type. So it was a mismatch. I had completely the wrong voltage going to the coil, and it destroyed the relay, and in the process it also destroyed other parts of componentry in that machine. As it shorted out, it overloaded circuits and caused havoc. So just be very mindful that when you choose a relay for a particular purpose, make sure the coil voltage is correct, that it's DC if you're using a DC supply, or AC if you're using an AC supply, and it is in its right range. I should mention here before we move on that if you plug a DC relay into AC, even if the voltages match, a lot of times that relay will destroy itself eventually. It'll try to pulsate, it'll turn on the positive cycle of an AC waveform, and it'll switch off during the negative part, so it'll be turning on and off, very high speed, and you may hear the relay chattering, a real vibration sound. And not only will it destroy the relay if left, it will also potentially destroy the load that it's switching, because it's turning on and off so fast that it can be very damaging. There are relays on the market that are dual voltage, dual types of voltage, AC or DC. They're particularly designed to tolerate the fact that they're not getting supply on the negative part of an AC wave, and they'll still stay held in for that duration. But just be mindful that they aren't as common as the other types of relay, so if you have a need for a particular voltage, it's far better for you to choose the correct type of voltage source for the coil. Now, mistake number 2, the wrong voltage level. Now, it's very important that you get the voltages correct, not only as I spoke about AC/DC, but the actual level of voltage, so that they can vary from 3.3 volts, they may even be different, but I know them to go as low as 3.3 volts right up until 480 volts. That's a huge range, and voltages have to be matched to the coil, so just be mindful of that. If you pick up a relay and you want to hook it up onto 12 volts, but it's only a 5-volt relay, once it's powered up you'll find smoke start coming out as it self-destructs. So just be aware that you must match the coil voltage to the voltage you intend connecting. Mistake number 3, contact voltage incorrect. Now you will find on the side of a relay, in most cases it'll have a rating not only for the coil, but it'll also have a separate rating for the contacts. So it's not uncommon to have a 5-volt relay that's 5 volts DC switching a 240 volt AC load. But you must match, or at least have the voltage rating higher than what you intend using. If you don't choose to do that, you might find that you get away with it for a while and think that was fine. I had it rated for 30 volts and I'm running 50 volts through it. You think, okay, that worked. It may work for a day, for a week, a month, or even a year. You never know. But there's a high potential that that will fail. And in the process, when it fails, it can cause devastation to other parts of the circuit, or even a potential house fire. So just don't do it. Always have it that the rating on the contacts match or exceed the voltage you intend using switching your load. Okay, the last disastrous mistake is having too high a current through the contacts. The contacts have silver added to them to extend the life of the relay. But every relay has a limitation on how much silver's been applied, how much material. It's usually a very good conductive material around that contact, copper or brass or some other highly conductive material, and it's rated for what the manufacturer thinks is a safe limit. If you exceed that safe limit, you have the potential for a breakdown. Now it can occur by arcing on the contacts when it's switching on and off, or it can occur by the fatigue of the type of metal that is passing current through that contact, through the silver tips and down through the contact. Eventually that material has a tendency to get soft from the heat of the current going through it, and as it gets soft it reduces the tension on the contacts, and then heat builds up and it just self-perpetuates until it destroys itself. So don't go exceeding the current rating on the set of contacts. So just to wrap up, to avoid any of the mistakes that I've listed, make sure when you choose a relay that you know whether it's AC or DC for the coil and the contacts. They can have opposite ratings, as I mentioned. Make sure the voltage is within the limits that you intend using, and that it can handle the current that you have passing through your load. Okay, that's it for the relay basics. If this video was too basic, we delve deep into circuits, components, programming and design and testing, and pretty much everything to do with wiring. We also will keep providing the less technical videos for the hobbyists out there. Be sure to leave your comments down below if there's something you'd particularly like covered. To enable us to keep providing free videos, please give us a thumbs up and share and subscribe to our channel. Until next time.